BizData gives the power to link any EHR system to another third-party system with eZintegrations. In this video, we shall integrate Oracle Cerner API with Oracle database to fetch patient details. To begin, log into your eZintegrations account. Navigate to eZintegrations and start by building integration bridge by clicking Add. Under Data Source, select Source Type as API. Choose Data Source as Millennium from the list and choose Business Object as Patient. Enter authorization URL with ID. Provide the authorization details. Add header details. Next, test the API endpoint using Test button. As we can see, our response in the source is of JSON data in a nested format, so we will have to convert the single-line JSON response to multiple lines tabular data as our target is Oracle database. Next, go to Operations to begin transforming, wrangling, and cleaning the data. We can see the list of all the operations by scrolling here. The first step is to fetch the data by sending nested values to the top using the operation send keys top of root. This retrieves the data from API and stores it in the key called BizData dataset response. So, this key has been passed. Using single line to multi-line operation, we will convert the single line data to multiple lines as the result is needed in tabular format. Here we can see the API response we received from our source. Data is stored under key named entry. This data is required to be converted to multi-line. Thus, we will be passing the key value as entry in this operation to convert all the data stored within it. Using the data extractor operation, we will extract all the details stored in the data. In response, all the details are stored within a key value called resource. We will extract the data by passing this key name in the operation. Using the operation send keys top of root, we are passing the key whose data we extracted before that is resource, to send the nested value to the top level and fetch the data that is stored in it. Next, rename operation is used to rename key value in our response. In response, ID has appeared multiple times. So, to secure the key value containing patient ID, we are renaming this key value named ID to patient ID. To eliminate unnecessary data, eliminate operation has been used here. The key values that are not required such as meta, text, identifier, extension, active and search, are passed in this operation. We will use operation send keys top of root to fetch the data by sending nested values stored under key value called name to the top. We will pass this key value in this operation. Using append operation, we can create a new column and save all the data extracted in it. Here, we are creating a new column called name1 and saving the JSON data extracted previously from name. Using operation send keys top of root, we will fetch the data stored in nested format in the newly created key value name1. Next, using eliminate operation we are eliminating some data that are not required in target. Now, using rename operation, we will rename key values as per our target. In response, key value text contains information of patient name. So we are renaming text to patient name using rename operation. Now, we will be performing the same operations for key value telecom as we did for name. First, using append a new key value called telecom1 is created and data stored within key value telecom is passed in it. Next, using eliminate key value telecom is eliminated. Then using send keys top of root, data stored within the new key created, that is telecom 1, is fetched. Next, using rename, key values are renamed according to target headers, such as system renamed to device and so on. Using eliminate, data in family, given, system, period, extension, rank, ID is eliminated. Again, we will be performing the same operations for key value address as we did for name and telecom. First, using append, address 1 is created and data stored in address is passed in it. Next, key value address is eliminated using eliminate. Then using send keys top of root, data stored within the new key value, that is address 1, is fetched. Using eliminate operation, data stored within ID, line, and period, in response is eliminated. Through rename operation, key value named text in response is renamed to address. Again, we will be performing the same operations for key value marital status as we did for name, telecom, and address. First, using append, marital status 1 is created and data stored in marital status is passed in it. Using eliminate, key value marital status is eliminated. Then send keys top of root fetches data in new key value marital status 1. Next, eliminate operation is used to eliminate key values coding, deceased boolean, communication and contact, as they are not required. Rename operation is used to rename key value text to marital status. Again, we will follow same steps for key value general practitioner, like we did earlier. First, using append, a new key called general practitioner 1 is created and value passed into it. Next, using eliminate, eliminating the old key, general practitioner. Finally, data of general practitioner 1 is fetched using send keys top of root operation. Using rename, columns are renamed as per our target, such as reference to practitioner associated, and so on. We have date column in our API response, so we will be defining date format using data types operation. Here, we are changing the date format from year month date to date month year of key value birth date. Once the data transforming process is completed, we will prepare the data to be sent to the database. To send data to the Oracle database, we shall create a new column using the append operation in which we are passing the new key value called new_key. Next, aggregation of all the values in one array is done using the data aggregation operation. Under group by key, we are grouping all the values available in the table using the new key created in append operation. Under array key, any name relevant to the dataset can be passed. Here we are using patient detail as our array key. Under array key nested column, all the columns created previously are passed. Lastly, a tuple is created for all the columns to read data from single line using single line to tuple operation. We are using this operation to load data in bulk in database, so we are mapping the columns along with the comma separated values. Informative and detailed documentation is available for each operation. Next step is to select target under data target. Before configuring data target, we will see how our table looks in target. This is Oracle database showcasing patient table with all the columns. The following step is to select the data target, which is Oracle database. To do so, we will be configuring the data target with database details, as can be seen in the video. Here, enter tuple key passed in single line to tuple operation. Once all the details are furnished, click on execute to check the running status of database. Now, in the summary section, provide the name and description of the integration bridge. Under schedule, we can schedule the frequency of integration or select interval as per requirement. Here, we are setting it to 6000 seconds. Once everything is done, click on Submit. The integration bridge can be seen in the list. We can now proceed to run the integration bridge and check the results in live streaming logs, since the integration bridge is now built. Data can be seen coming to the target. With eZintegrations, get a seamless and faster EHR integration experience.